Hey everyone, and welcome back to another Desmos graph tutorial. Um, so, uh, so previously in our dog graphing tutorial, we finished pretty much all of the essential facial features. We just need to finish off the outline of well, his face. Um, so to to start, first thing that noticed that since when I was drawing this in paint, the shape was getting out of shape. So I'm not going to follow this line exactly, otherwise this graph's going to look as ugly as the background picture. With that said, I'm not going to follow a line closely. I'm just going to pick a line that at best resembles the shape that I was going after, which is very similar to this tongue shape. And I'll show you what it is, and that is, see if I can figure out what it is. Let's see why. I'm solving this top equation right here. So this looks like y is going to be a square root of some kind. 1 minus x to the fourth. There we go. That wasn't hard. And then 400, what am I talking about? And then I'm going to move it up to this point. So this is fitting. So this is curving off at 4 really nicely. So I'm going to add one less than the top, which is 3. Then from here we can do a bit of adjustments. So we can perhaps like make this like slightly thinner. So we start with 1 to the 4th power, even though it's 1, so we can easily manipulate it however we want. So I want to make this like slightly bit thinner. I'll move it down by a tad bit. Well, first I'm going to elongate it by a tad bit. Let's see how this goes. Be a little more precise. So which means it's going to be now 2.875. And I'm just going to go with this shape. Right, and then I noticed this shape is curving down from here, and it's going to bend back outwards. So there are two. Actually, there are several graphs that have this shape. There is, I should say, there are y. Oops. There is the y is equal to cubic function. So it's a regular plain cubic function, and obviously we switch it. It's 1, and then we also have a very similar looking graph, cotangent. Not use tangent because then we're going to have to flip it over by -1. And then we also have what's it called? Oh, of course, sine inverse of x. Cosine's better. It's facing the way we want it to be facing. And the one that I'm going to be going for, all of these are good shapes, but the one I'm going to go for is the arc cotangent because well, I'm going to do a bit of calculus here. the tangent line at the very tip right here is vertical, and that matches the tangent line at this very end point right here, which means in other words, it's going to line up perfectly. In most cases, we don't get perfect, but in this case, we will get perfect. So first, we need to find out where this point ends, which we'll assume is some multiple of 1/8. I want to try. Is there a way to calculate what this y value is, or let alone this x value? I'm trying to measure this. 7.5. Then went to 8.78. That is slightly disturbing. Okay, this is 1 point. This is 1 right here. This is not even 1. I'm taking some time to think it out, and we can always give some numbers a try. So let's start somewhere. And this point is going to be its assumed y value, 2.875 minus 1. So this is actually no reason for this to not be 2.875. So I'm just going to go down. This is 2.875. That means this has to be. So first I'm going to center this at 2.875. Okay, so now this guy's at 2.875, and it's and the distance from the top to the bottom. We just take the vertical distance. That's going to be, let's see, 2 pi divided by 2. That's pi. Let's subtract pi from that. That's looking better. And just so we don't have to do any more adjusting, we can maybe scale this down by a little bit. And then even just press it by a little bit. I'll move it over by half a unit. So 275 is going to be 1.625. And then go ahead and just make this 3.5. 625 by the looks of things. And then we have to figure out how much this is shifting over, because it's not truly that. So if I 0.5, it's too far to the left, and if I do 65, it's too far to the right. I'm gonna do a calculation on what that number is, and I will be right back with that. All right, so it turns out that the value before we do anything to the graph, well, by that I mean like compressing and stretching, all things they would do to fit the graph into a perfect mold. So it turns out that in order to line this up with this point right here, this is how much you would shift it to the right. So if you have any questions on how I did the calculation, do you ask in the description, and if I get enough like frequently asked questions on that, I might do a separate video on how the calculation was made. Also, do not duplicate each other's comments. Instead, if one person already asked it and you have the same question, just like that person's comment. I don't want to. So if you get like 10 comments asking for the same thing, it's going to make it even harder to parse through all the comments. Not that I get many at this point. Anyways, so to go back to the molds, I don't have the exact numbers, but I believe this is what they were. So if I use 0.75, that means I'm going to shift it up by that amount, and then inside this part, we might want to compress it by 0.25. I believe that was what the number was. And that means we have to shift it to the left by another. Is actually going to throw off the calculations? It does. That's annoying. You undo all this. Let's see, what number is close to 1.25? Try pi on 2 to see if that makes things any easier. Oh, I see what I did wrong. I'm going to do with that. Look inside here. No. That. Just might have something to do with it. I'm going to fiddle around with these numbers. And just maybe I get something nice out of that. Looks like it does have something to do with pi. Alright then, since we're still here, we can just reflect this over. So instead of making that, we're going to add, and we're also going to the entire thing around. The minus here. Oh, that stays as a plus. I'm not using any real logic here. Okay, plus 1.125. And then I'm going to shift it to the right even more. Okay. Okay, this is not lining up nicely, but it is. Well, that's because this right side is chubbier than this left side right here. All right, and then to finish it off, I want to use a half ellipse. So I'm going to start with the basic equation as usual. We don't need any parentheses for that one since it's centered at 0. And then We can shift it up to where this point is. This is nice and convenient. Is it? No, not by 1, but it is. And then we want to bring it down by half units, so entire 1.5, 7.5. I'm going to stretch it out such that it's going to get at this point. Okay, I want to try something here. 2, but I'm going to add 1 over 0.125. That's too much, so I'm going to have to start cutting down. Gradually reducing. Okay, that's too much. And this is, I don't see having to get any more perfect than this. And then just to make sure we're happy with this, instead of just going off of how accurate our picture is, just call these in, delete all this. Move back. This is turning out pretty nicely. And I hate to notice that some of these lines are a little bit off. That's okay. Calculators aren't always perfect either. Might be one of those times. But anyways, took us a bit of while to get 1, 2, 3, 4 lines. Right? 1, 2, 3, 4. Yeah, 4 lines. Took us nearly 15 minutes for that. Anyways, sorry, a bit fast at the end. And then, as always, ask any question that you have. Leave a like if you found it useful. And other than that, one more thing. I have an announcement video coming out around about tomorrow, I believe. So, so please do check out, not a tutorial video, but an announcement video with the pretty important stuff. So I highly recommend go ahead and over there and check it out. So on that, I will see you there.